Hello friends, welcome to video lecture on fluid mechanics. In the today's session, we'll learn about the hydrostatic force on a curved surface. So let us start. Here the curved surface submerged in liquid. Okay, this case we have taken for the study. Consider a curved surface AB submerged in a static fluid as shown in figure. Let dA, this one, dA is the area of small strip at a depth of h. Okay, this is the depth we have considered from the free surface of water. Here is the free surface of water. Then the pressure intensity on the area dA is rho g h. Okay, and the pressure force dF equals to P multiplied by area. So P with us here rho gh and area with us dA. Small area we have considered, that's why the dA is written. Okay, so this force dF acts normal to surface. This force, this one acts a normal to this surface. Is the total pressure on the curved surface should be here F equals to integration of this term rho gh multiplied by dA. If you just draw a large picture of the same. Okay, so if you just see this angle with this angle made by this area with this tangent line is nothing but the theta, automatically we can get this angle as theta. Okay, so this is nothing but the dfy and this is nothing but the dfx. Okay, we'll discuss these two forces in the coming part. Okay, so before that, if I draw here an enlarged diagram of this one, so here we can get the dA. So the inclined line is here dA. Okay, the angle with us theta, and we just here EG portion we have considered EG and F. Okay, so adjacent side of this one is nothing but the dA cos of theta, and this one front side of this theta is nothing but the dA sin of theta. So if you look to us this relation F equals to integration of rho gh into dA. So here the direction of the force on this small area, here the small area I considered, is not in the same direction but varies point to point. So point to point variation in the force acting on this area uh, takes place there. Okay, so integration of equation, this one, for the curved surface is impossible. Okay, so the problem can be however solved by resolving this force, this df force, into its components. Okay, so the component along this direction is nothing but the dfx and this indicate the dfy. Okay, the total force in the x and y directions is nothing but the fx towards the horizontal axis and fy is nothing but the towards vertical axis. Okay, so integrating dfx and dfy, we can get the total force on the curved surface. Okay, integration of this one. Okay, so the total force here F can be analyzed with the help of this relation square root of fx square plus fy square, and the inclination of resultant with the horizontal is tan of phi equals to fy divided by fx. In this way that can be analyzed. Then resolving the force df given in previous equation, that is in equation number this one 3.11. okay, so along x and y direction, okay, we can just resolve that force. If you just see here already the resolution in front of you, this indicate the dfx and this indicate the dfy component. Okay, so we know dfy component, this one dfy component is nothing but adjacent with this theta, means this component must be cos component and this component must be sin component. So you can get this df is nothing but, sorry, dfx is nothing but the df sin of theta. The horizontal component must be here sin component and here vertical component must be cos component because angle theta is here. Okay, so we can get this df sin of theta equals to, so what's about this df term already with us rho g h into dA into sin theta. Okay, will remains as it is. Similarly for the dfy, you can get df multiplied by cos of theta, so this term will remain as it is multiplied by cos of theta. So you integrate this term dfx and dfy, so what do we get? We can get the total force value. So Fx is nothing but the integration of dFx equals to this term will come as it is. So just take this rho g outside of this integration sign and remaining term just write instead of that integration sign. So h into dA into sine of theta. Similar case for the Fy. Okay. Now if you just see the second diagram, from this second diagram, if you just say this EF indicate the DF. Okay. So this EF is nothing but the DF and FG is nothing but the dA into sine of theta. Similarly, this EG indicate the dA into cos of theta. Okay, in this way. Now just look towards this equation. Okay, so dA into sine of theta is nothing but the FG, vertical projection of the area dA, and hence the expression rho G into integration of this one h into dA into sine of theta represents the total pressure on the projected area of the curved surface on the vertical plane. So here is the vertical plane with us. Okay, so apart from this one, if you just see here, Fx is nothing but the total pressure force on the projected area of the curved surface on the vertical plane. Also this dA cos of theta is nothing but the Eg. dA cos of theta is nothing but the Eg that will add on a horizontal projection of dA, and hence HDA this one HDA cos of theta is the volume of the liquid contained in the elementary area dA up to a free surface of liquid, Thus integration of this term h into dA into cos of theta is the total volume contained between the curved surface extended up to free surface. Okay, hence this rho g, this term rho g into integration of h dA into cos of theta is the total weight supported by the curved surface. Thus this Fy is nothing but the rho g into integration of h dA into cos of theta. Okay, this must be equals to the weight of the liquid supported by the curved surface up to free surface of liquid. Now if you just see this picture, the curved surface AB is not supporting any fluid. In such cases, Fy is equal to the weight of the imaginary liquid supported by this one AB up to a free surface. AB up to free surface of liquid. The direction of Fy will be taken in upward direction. So here direction of this Fy is taken in upward direction. Okay. So if you look towards the problem given on these topics, this figure shows a gate having a quadrant shape of radius 2 meter. Find the resultant force due to water per meter length of the gate. Find also the angle at which the total force will act. So here the radius of the gate with us 2 meter, 2 meter radius is given, then width of the gate is given 1 meter. Okay, so apart from this one, Fx indicate the force on the projected area of the curved surface on the vertical plane. Okay, so here is the vertical plane with us. On this the horizontal force is acting. So my target here to get the value for this A and H bar. Okay, so this A is nothing but the area of this one BO, the vertical this one radius for this one with us 2 meter and width is given 1 meter. So I can get the area for the same as 2 meter square. What's about this H bar? H bar is nothing but the total this one height with us 2 meter. Half of this one is nothing but the H bar. Okay, so we can get that as 1 meter. So what's about the next one? So first of all, get the value for Fx by substituting the value for this H and H bar. Okay, so what do we get here? We can get, after putting the value of this A and H bar as 2 and 1, we can get 19,620 Newton. So this will add at the depth of 2 by 3. If you just see here, this will add at the depth of 2 by 3 into 2. Okay, equals to we can get 4 by 3 meter from the free surface of liquid. Now how this actually depth is taken here? For that it is very important to just take a revision of that centroid topic studied by you in first year. Okay, in under that engineering mechanics subject. Okay, so very simple one. For the various shape, the standard values are there. You have to just remember the x bar and y bar values depends upon various shapes given. Here the quarter circle with us. Okay, for that you just see the from the free surface, we are getting the depth of this one as 2/3 of 2. Okay, 2 total height is given here. Okay, so this is nothing but in terms of radius r. Okay, so in this way I can get the 4/3 meter from the free surface of liquid. Now what's about the vertical force Fy? Fy is nothing but here weight of the water supported by the AB, supported by this AB. So what's about the weight of the water here? Rho g multiplied by area of this AOB multiplied by width with us 1 meter. So 1 meter already written here. Okay, so area of this AOB is nothing but the pi by 4 into this one. Here actual r square with us. Okay, here we can get in terms of this one. Okay, here the formula with us pi by 4 into d raised to 4. Okay, in this way formula with us, just substitute all the values here. Rho with us, g with us, area, okay, can be calculated with the help of this formula. Then okay, width with us as 1, so get the value for this one. Fy is 30,819 Newton. We'll get after calculations. So this will adds at a distance of 4r by 3 pi, 4r by 3 pi. Okay, this also you need to just focus on that centroid topic studied in under that engineering mechanics subject. Okay, for the standard shapes, already in the previous lecture we have just shared that the values of the moment of inertia along with the areas for the standard shapes. Okay, just remember the value for that x bar and y bar. Okay, so similarly you can get the value for the location of the vertical force. Okay, vertical force with respect to this this plane. So horizontal distance we can get 4r divided by 3 pi. So from the this one OB plane is here, with respect to this one you can get the location is Fy. Now if you just see here, the resultant force F is given by Fx we know, Fy we know. Okay, Fx already with us, this one Fy already with us. Okay, so get the just substitute here in place of Fx and Fy and get the value for the force. Okay, so this is nothing but the resultant force or total force by considering the horizontal force as well as vertical force. So we can get the value for the same as 36,534.4 Newton. Okay, now next task is very easy. So angle made by this resultant with the horizontal can be calculated by using this relation tan of theta equals to Fy divided by Fx. So Fy already with us, Fx already with us. Okay, so in this way after doing calculation we can get the value for theta as 57 57.31 or 57 degree 31 minute. Okay, in this way we can get the value for the same. Thank you. I hope that the concept discussed in today's lecture clear to you.